Hey everybody, this is Dan, the Storage Doc, coming at you from Reliant Technology again. It's another month and we have another episode of our podcast for you where we talk about all things storage. If you're new to the podcast, we got a couple of different segments. The first part, we try and take questions that are more overview related, conceptual, designed for maybe IT managers or IT newbies that are just basically saying, I want to get basic information about storage and storage networks and how things do what they need to do, just to understand more and get a place to start from. A lot of times it's intimidating to figure out where to start when you're building a SAN or researching a SAN. And then in the second half of our podcast, we'll be doing a deep dive for those of you who are familiar with that. And that deep dive usually comes from a chat question or a question that we've been asked here in an actual client situation. So with that, we're going to get started. I think we have Eric on the phone who wants to ask a general question. Eric, you there?
I sure am.
Okay.
I'm new to SAN storage, and I need help understanding the components of the SAN and how each component impacts the operation of the SAN.
Okay, so you're saying you want, you're looking at maybe what are the basics of a whole storage network and how do those pieces work together?
Yes.
Okay. It's a great question, and you know, when we're talking about storage and storage basics, we kind of want to look at, I mean, the best way to look at it is kind of like almost like a building block. So this is kind of how I describe it. So let's say you got your building block and it's got 4 sides, and each one of those sides represents a resource. So one component is going to be your processor, or just processing in general, the ability to translate commands to and from the storage system. One is going to be the actual storage itself, of course, which is what most people talk about in terms of gigabytes, terabytes, etc. Another one is going to be your cache. And cache is what's used as a temporary holding place for commands that come into the processor but can't yet be written to storage. And then lastly is your network, which is how you get the data to and from the pieces that are requesting it. So if you want to take a look at it like this, essentially this entire piece right here is your storage device or your storage array. That's how you'll hear people talk about it. Oops. And they say a storage array, or they say a filer if they have a NetApp, or they'll say my head unit, or something like that. This is really what they're talking about. It's usually a 2-rack unit or a 3-rack unit device that does all of these functions and takes a group of disks, writes information to them, spits them back out to the servers or the clients that need to get that information. So those are kind of the basic components. Now outside of that, what you'll connect to that will usually come down into a storage switch or another kind of switch. And then that in turn is connected to servers. or it may actually be connected to individual desktops in some cases, depending on how we're using the storage. So you have a server, which usually what most people are doing when they're building their first SAN is saying, well, am I still going to use my hard drives? You might still use your hard drives for some things, like if you're doing VMware or Hyper-V, and you need to load something called a hypervisor onto your servers, which is like an operating system allows you to build virtual machines on top of that. You might load that on those local hard drives and then actually put your data up here on the SAN array. Then how does the server get that data? Well, typically it goes through a dedicated switch via fiber or Ethernet, depending on how you set it up, and then it comes into your storage array device. You can, in some cases, especially if you have a small implementation, connect your servers directly to the storage device itself. So that's a little overview of how the storage network as a whole. So if you want to call this, if you were talking about what is a SAN? A SAN is a storage area network. So the network is this whole thing, right? Some people, when they say SAN, they're talking about this, just the storage array itself. But most properly, the term SAN means the entire network, the entire storage infrastructure and how it's put together. So if you're talking with people that are more experienced and have been around storage a long time, and you say SAN, they're probably going to be thinking, I'm talking about my whole infrastructure, not just the storage device itself. So that kind of gives you a little bit of an overview, and you can see there's a lot of moving parts to it. And as we, as we get more into the podcast and we start exploring more of these topics, as people ask them, you'll be able to see how these parts interrelate better. In particular, how we size up the storage to match the needs of the server and things like that. So I hope, Eric, that answers your question, and feel free to ask more, in another episode, and we'll continue going from there. So that's our Reliant building blocks for today. That's kind of our basics. And with that, let's move to a question that's come in via chat and kind of go to the second part of our podcast, and that's where we talk about more of the kind of an in-depth technical review of something that's come up that people are asking about. And from our chat, I see somebody's been researching their SAN, and they have a couple of different, they're looking at several different vendors, and they want to know how a lot of people talk about write caching, and what is write caching, and how does write caching actually work across different vendors. And so so let's look at that for a minute. So write caching, just so everybody's clear on what I'm talking about. And this is what this person is talking about. We're not talking about auto tiering. So auto tiering, it might be where, say, you use an SSD or a higher speed drive as part of a single storage pool, and the data gets moved around between those pools automatically as a storage function. Okay, that's auto tiering. Cache is a different technology, a different purpose. It's separate from the storage. So auto tiering happens within this resource pool. Cache is its own resource pool, okay? And cache is not limited to any one storage pool unless maybe you set that up to be that way But typically, most customers just have cache in general for a storage system. So let's talk about that and how that works. So if we look at our major manufacturers, we've got HP 3PAR, we got NetApp, we've got EMC, we've got EqualLogic, we've got IBM, and we've got Compellent. All of these have caching to some degree or another. And the question is, what kind of caching are they doing? And how does that caching affect your performance? So when people talk about write caching, the reason they're talking about it is because writes to a disk are inherently slower than reads. So typically when you're sizing a storage system, the thing that you have to adjust most is how much storage you need based on the percentage of writes that you're going to have to a system. Writes are harder for disks to do because when you write data, we add something called parity, which is like a double check. It's a check that says the data that I just wrote is actually intact, and in case you have a disk failure, this parity data that's been written in addition to the actual data of the file can help us reconstruct a disk that's failed. That way you don't lose your data. Now the downside of that redundancy is it has a hit on performance. So people look at write caching as a way to mitigate that and to say, I can get some better performance out here by taking my writes and sticking them up into cache where they can be processed until they get written to the storage, and then the cache is flushed and made open for another similar opportunity. So that's what we're talking about with write caching. So there's a couple of different ones, a couple of different ways that the vendors do this. So EqualLogic, Compellent, and to an extent IBM mostly do a traditional cache, okay? So we'll call this traditional. And traditional caching, you'll see something like 4 gigabytes or 16 gigabytes, something like that. But it's going to be double digit kind of thing. And what this cache is really cache just for basic operations. They do help somewhat, but a 4 gig cache, a 16 gig cache, not huge. And you know, if you're working in a system with multiple terabytes, this is really not that much. This traditional caching methodology is really designed to protect against power outages. So you have a power surge in your network, or a flash, what we call a brownout, where the power dips a little bit, or some other symptom that causes the storage to be temporarily unavailable for a little bit. You don't want the writes that have been sent over to the disk that haven't been finished processing on the storage to just not finish. So the cache exists in a small amount to make sure that in the event something happens, the remaining commands here can be written when power is restored and the condition is repaired. Performance-wise, the gain is minimal. I mean, it's not huge, it's not bad, it's what we'd expect from traditional storage systems. For 3PAR, 3PAR has something called persistent cache. And 3PAR does it a little bit differently. 3PAR operates their SAN as cluster nodes. So in a sense, in a 3PAR storage device, you would have multiple storage nodes, up to 4. Okay, just like this. And persistent cache actually mirrors cache in a mesh format, you know, etc., between all the nodes. And what this gives 3PAR is the ability to take a node down, say for maintenance, like this, and to have all this cache stuff still available on the other nodes. So in a sense, it gives you almost like a cache redundancy, and the cache is typically bigger than this. It's more in the 3 digits of gigabytes. But it gives you something that the other ones don't. In a traditional setting, if you take a controller down, you lose half the cache. With HP persistent cache, you don't lose half the cache. You still have just as much cache as you had. I mean, physically you have less, but the actual cache data here has already been mirrored over. So that cache data can continue to be written and continue to function without having this other storage node there. So that's a pretty good benefit. With NetApp and EMC, they kind of have an additional level of cache, and that additional level goes beyond just your traditional RAID caching methodologies like we talked about here, and it's not the same as persistent cache. The way that NetApp and EMC do it is, it's just not working. NetApp calls it fast cache, and EMC calls it, I'm sorry, wrong way. See, I got it backwards. Flash cache, and NetApp calls it fast cache. Or I'm sorry, EMC calls it fast cache. You can see why it gets confusing right away. But if you're familiar with EMC, you know that this fast is part of their fast VP series of products, and this is part of their flash cache. What these are is these are actually PCIe cards that are built on flash-based solid-state memory. And they come in different sizes, typically 256, 512, and 1 gig. So these guys, or 1 terabyte, I mean, these guys go way up there, 256 gigabytes to 1 terabyte per card. And depending on the storage model you have, you can have several of these cards. So in the high end, a NetApp 6280 can go up to 6 terabytes of cache per controller for 12 terabytes of active cache. It's a huge amount. And EMC scales up just about as high. And the difference between these guys, because their cache is so much bigger, you can operate a lot of things out of that cache. So for example, if you have a large virtual desktop environment where you have, say, 5 or 10 common images, something like a fast suite or flash cache can really help mitigate against I/O storms like a boot storm, where you come in Monday morning and everybody 8 o'clock powers on their virtual desktop and your storage system is just getting slammed and slammed and slammed. But since the desktop images are the same, the system knows, hey, I can pull that image into cache, and now I'm responding out of cache, out of flash memory, which is insanely faster than your traditional 15K drives. Most of these guys, they don't really put out IOPS ratings, but my experience, cards like this get the equivalent of hundreds of thousands of IOPS as opposed to tens of thousands with traditional disk systems. So that's kind of the basic difference. And flash cache and fast cache by default is spread across all the LUNs. So any LUN that's on an EMC or NetApp device can take advantage of cache as opposed to something like auto tiering, which is generally within one storage pool. So the question that you need to ask yourself when you're looking at write acceleration is which one best matches my needs. For someone who's doing a lot of writes, like in a virtual desktop environment, for example, these guys really make sense. Excuse me. For someone who's looking really high on redundancy, 3PAR has got a really good track record for that. But if you don't need any of that, then you're looking at your traditional systems. Their caching rates are just, or the caching schemes are very traditional, very reliable. The one major difference with EqualLogic is it's pure storage architecture. So as you add EqualLogic nodes, you can have up to 16 boxes in a cluster. So you can actually increase the amount of cache of the overall system by adding nodes, which is a good advantage. So that's a little bit of an overview about write caching, and hopefully that gives everybody a good idea of how it works. So stay tuned for us for next time, next month. We'll come at you with another storage doc. Until then, thanks for watching.
This podcast has been brought to you courtesy of Reliant Technology. Visit us online at www.reliant-technology.com.